Hi friends, now in this cold chain logistic training module, I'm again here with you for discussing on the specific module, that is packaging of frozen foods. We know the packaging materials and packaging of foods, which are very important and interrelated as well. We try to understand the different packaging materials and their associated properties, and how the food materials and its compositions, and during storage the different volatile materials which are coming out from the food, how it is interacting with the packaging material. So we can see the packaging of frozen food and their properties in terms of the food and the packaging material. Packaging material may be of different kind. For example, the paperboard, which is molded pulp that have poor barrier properties but good structural resistance, and which provides protection against physical damage. Plastic materials with excellent moisture, oxygen and aroma barriers. So these barriers, like for the moisture, oxygen and the aroma, generally maintains the quality of the food definitely, but at the same time the increment of oxygen inside the stored food, say packaged food, it may fast the ripening process. But since it is a frozen food, so this problem generally does not come infrequent. Other packaging material like semi-rigid plastic containers that have good structural properties, aluminium that is a total barrier to moisture, oxygen and aroma. Most commonly used low density polythene and high density polythene and polypropylene, these are having excellent moisture barrier properties but poor oxygen barrier properties. LDP used as a flexible film, pouch or as a coating on paperboard. Heat resistant HDP and PP film pouches are used for boil-in bag or microwavable pouches. The next packaging material like PVDC, polyvinyl chloride, and another is the PVC, polyvinyl chloride, which is a kind of copolymer, and it is having excellent moisture, oxygen and aroma barrier properties. Another material like EVO, ethylene vinyl alcohol, which is again a copolymer, and polyamide, which are having poor moisture barrier and excellent oxygen and aroma barrier. So we can see these are the materials which are, some is having good oxygen barrier properties, some are having good aroma barrier properties, and some is having poor moisture barrier properties, like this. So we can see the different food materials are having different interactions with the food and the moisture, oxygen and aroma of the food as well. Another material like PET, which is having good moisture, oxygen and aroma barrier properties and good heat resistant. And this is the additional advantages of the PET related food material, packaging material. PET can be used to form trays or coated paper board trays that are dual ovenable. Coating the LDP or HDP with PET or PVDC increases the oxygen barrier properties. Crystalline polyethylene tetraethyl having better heat resistance than the PET. So some is having some favorable properties, some may not have. Accordingly, we have to decide which kind of packaging material we can use to pack and to wrap the different type of products. So the selection of packaging material depends upon the nature of the products as well, which are need to be packed. Irreversible dehydration will occur at the surface layer of the frozen meat unless it is packed in vapor resistant and airtight material. Trays that are formed from foamed PS have very low density but produce a rigid material. The skin tight PVDC film package is mandatory in case of poultry and its pieces are put into the bags. Then they are transferred to a rotary vacuum machine which packs the poultry product with clip closures and bag along with neck trimming. When the bags are shrunk, they form a second skin around the poultry. Then they are either frozen in drying or in blast freezers. The function of oxygen barrier is enough to prevent fats from becoming rancid, and the water absorption is negligible. PVDC film and serious range of laminates with PE are the most common materials used for packaging. PVDC is used in vacuum packaging mainly for packaging the frozen foods. It is better alternative to glazing process and it eliminates moisture loss in initial freezing. We can see other different kind of attributes which are related with the food products when it is packaged in a particular packaging material and is stored in the low temperature. Like the drip loss on thawing and weight loss on glazing is also eliminated. It reduces the labor and time needed for traditional glazing. The fish is able to retain its fresh characterization by light vacuum package along with the entire distribution process. PET film packaging material is also used for fish products to be kept in pillow pack style. The film is laminated with PE, and this lamination of packaging material possesses good barrier properties. PET is puncture resistance over a wide range of temperature, and thus it gives protection to product during transportation. On a large scale, majority of frozen fruits and vegetables are packed in plastic films such as deep freeze grades of PE. They are made into pillow type packs on vertical form film seal machines. LDP are generally used as moisture barrier in vegetable packaging, and ethylene vinyl acetate bags provide mechanical resistance for large weight of product along with the necessary moisture barrier. Some of the examples are represented in terms of the figures which you can see over here. Shelf life, which we can see especially for a freezer burn shelf life, under which we can see freezer burn occurs when ice crystals or other moisture on the surface of the product evaporates, leaving grayish white spots on the surface of the product. As evaporation occurs and the freezer burn develops, oxygen can come in contact with the food, creating further deterioration of the food product. Another point, proper packaging that retains moisture can help reduce freezer burn and extend product shelf life, and which we can see in the figures which are displayed in this slide. In this slide, we try to understand what are the trends which are going on, especially in frozen food packaging. So, in terms of the smart packaging, we can smart packaging. The another component, active packaging. In terms of active packaging, we can see the different kinds and different types of system. That is, first one, the moisture regulators, which is generally governed by the moisture absorbers. Ethylene removal system, which is governed by the ethylene absorbers and the scavengers. Carbon dioxide scavengers. Antimicrobial active packaging. Based on CO2, ethanol, natural extracts, inorganic nanoparticles, and other preservatives. Antioxidant and oxygen scavengers, thermal insulation packaging based on the phase change material. This phase change material, which is now very popular and which can be used as the thermal transition material nowadays for the storage of heat and for the insulation as well. The type of system under which the another indicators like the time temperature indicators, freshness indicators, and gas indicators. In terms of sensors, we can see chemical sensors that may be electrochemical based or optical based, biosensors that can also be electrochemical based, optical based, and some are edible sensors which are associated with the food products, and even when we consume it, there is no problem at all. Data carriers generally which are used for the informations that may be represented in terms of the barcode labels and the RFID tags. The properties in terms of does not act on food, monitors the condition of the product, provides informations as well. Active packaging, under which we can see the performs some desired role other than providing an inert barrier to external conditions, enhance the performance of package by changing the condition of the packaged food to improve the quality and the shelf life. Protective active packaging, under which it includes oxygen scavenger sachets, labels, closure liners, and films that complement the oxygen barrier property of the package. Increases the protection of the oxygen sensitive frozen foods. In some other concept like convenience active packaging, we can see they are stable to the conditions of the microwave or the conventional oven, dual ovenable, and can serve as a convenient container for preparations, services, and the consumption of the frozen foods. Incorporation of susceptors in microwavable packaging allows crisping and browning of the products, and that these convenience actually related with the microwave assisted conditions. Some of the commercially available active packaging for the food products which we can see from this table, the commercial name like Biomasters, Pure Temperature, Tedder Base, Peak Fresh TM, ATCO, Food Touch, and the principles we can see, especially in case of the Biomaster, the principle behind it is the microbial based actions. In the Pure Temp, the phase change material actions, and the Tedder Pack where we can see that the moisture absorber based principle mechanism is there. Peak Fresh TM, ethylene scavenger, ATCO, CO2 absorber, and the next one that is antimicrobial, and which are applied for the different products, and we can see all these commercial name are also differentiated in terms of the materials and the forms. Intelligent packaging. Why intelligent name is there, though it is associated with the active as well, but intelligence in some different way. Some intelligence concept and some sensors are there which makes it more intelligent to understand, to track the informations. The simple intelligent packaging contains components that sense the environment and the communicate informations important to proper handling of the food product. Interactive, responsive, intelligent packaging responds to environmental change and thus prevention of the food deteriorations during the transportation as well as during the storage. Another type of kind of intelligent system that may be the barcodes to radio frequency transmitters, which definitely give the informations, accurate informations of the product during the storage as well as during the transportations under particular temperature stored conditions. TTIs, that is called the time temperature indicators, are often self-adhesive color changing labels that respond gradually and irreversibly to the cumulative exposure of the produce to temperatures. So through this we can understand, we can track as per the elapse of time how the temperature is going to be changed, and we can gauge the temperature accordingly. The owner and even the stakeholder can understand the status of the food and any kind of changes which is being assisted by the temperature as well. Erroneous type of temperature behavior of TTI does not take into account the concentration of effect. ice crystal growth and the glass transition phenomena of the frozen foods. So through Arrhenius concept, we can understand the temperature changes and activation energy, but sometimes it is very difficult to understand how the physicality is going to be changed in terms of microbial enzymatic actions and some other actions. The time temperature indicators, in case of perishable products, the temperature is the most important in determining the shelf life of a product, and that can be understood by the help of the Arrhenius relationship, which I have just discussed before this slide. It's challenging to avoid temperature fluctuations. Time temperature indicators give valuable support in this regard in order to address the challenges related to the temperature fluctuations. Three types of TTI, that is time temperature indicators, are there. Partially history creator, which responds when the predetermined limit of temperature is exceeded. Second one, full history recreator, a complete past creator responses for temperature fluctuations. And the third one, that is enzymatic, which responds to changes in the biological activity of the spores, microbes, and the enzymes. So this is what we can say the biochemical actions. Any kind of biochemical actions which are going to be occur in the products which is stored at a lower temperature or being transported as well can be tracked by the enzymatic concept of the TTI. Another packaging system, that is flexible packaging, which we can see in the different way, that convenience for the consumers, visual and handling appeal, packaging material source reductions can be based on a single layer of plastic material or combination of materials that can include several different plastics, papers, aluminium. And the next point, that is not currently recyclable, that may be one problem. Okay, include resealable pouches of IQF foods. IQF stands for the individual quick freezing. Standard pouches for frozen foods, and modified atmospheric packaging of frozen foods that will later be thought for sale as frozen phase. Microwavable trays, curtains, and balls. Semi-rigid or rigid plastic trays and balls and PP-coated paperboard based curtains have been developed as alternative to aluminium for frozen entries and the meals. So these are the recent advances, and definitely which have been taken place in the many 10 years and the 20 years development. So use of the paint coating on paperboard produce greater food crisping and the browning. The non-thermal food processing technique in combination with freezing that can be employed. Okay, and in that conditions, what kind of packaging material are required in order to pack the food? Like radiation, HPP processing is generally performed on the pre-packaged foods. Irradiation has been found to affect the properties of plastic and paper packaging materials. So modification of mechanical and the barrier properties of the plastic material. In this case, the packing involved must be evaluated to ensure the food safety and the quality. So these points, why these points are very, very important, because some of the packaged foods are generally get treated with the irradiation, like we can go for the gamma radiation concept, and even for the non-thermal processing like the HPP, pulsar electric field. So different concepts under which if we are going for the treatment of the packed foods, in that conditions we need to evaluate the safety of the foods. Why? Because after package it is going to be treated out. So is there any residual effect of the concepts are there on the packaging material or not? So modified atmospheric packaging complement freezing of for foods that are quite sensitive to oxidation, such as fish, and for foods that are thawed and marketed as frozen fresh. Frozen bread packed in nitrogen and carbon dioxide atmosphere has longer shelf life after thawing, allowing wider distribution and sale for frozen fresh. Frozen foods packaging as a commodity specific. So if you'll see, as per the commodity specific, even though in the previous some of the slides we have discussed as well, but in a specific manner, that for example, first one, that is the frozen meat. The fat in frozen foods will eventually turn to be rancid and if exposed to light. So we need to select a particular packaging material in order to reduce the light effect so that it could not go under the rancidity. Irreversible dehydration will also occur at the surface of the meat unless it is packaged in airtight, vapor-resistant material, for example, plastic bags or trays in conjugation with stretch wraps. Freezer burn is due to the dehydration of the surface of the unpacked or badly packed frozen meat, which can be reduced and can be solved and resolved by using the specific packaging material. Freezer burn becomes progressively worse when badly wrapped frozen meat is stored for long time and the grayish white marks appear on the long lean surfaces of the meat. To protect frozen meat from rancid and the freezer burn, PE bags and PVC or PVDC films are used with EPS trays. So the changes which are being taken place in the packaged food, through which we can actually understand and we can decide what kind of packaging materials can be used for what kind of products. Frozen poultry. So it is prepared, if the poultry products are prepared and inserted into bags and transferred to a rotary vacuumizing machine which packages the product with clip closures and the bag neck trimming. So this prepared poultry, specifically if you want to store, if you want to package in PVDC film, then in this way we can move ahead. When shrunk, the bags from a second skin around the exact contours of the birds, which are then either frozen in brine or in blast freezers. Prevent freezer burn, and water absorption is negligible and function of the oxygen barrier is sufficient. So material used for packaging includes PVDC film and range of laminates with PE. So in PVDC film, through the vacuumizing machine, under which we have seen what are the merits and the demerits and how it is acting and what kind of changes are there which can be reduced thereafter. Frozen fish. So most of the fish begin to freeze at about -1 degree Celsius, and the multiplication of putrefaction bacteria is stopped at -9 degrees Celsius. Protection of frozen fish is needed against evaporation in cold storage caused by the transfer of moisture. Glazing is generally performed to avoid the above phenomena. PVDC is used in vacuum packaging some fish, such as whole frozen salmon. This system provides a better alternative to glazing process. It eliminates moisture loss on initial freezing, drip loss on thawing, weight loss on glaze, and reduces labor and time needed for traditional glazing. The PET film, which is also used for fish cakes in pillow pack style on horizontal form fill seal machines. The film is reverse printed on the treated side and laminated with PE. This laminate possesses barrier properties and is puncture resistant over a wide range of temperature, giving protection during the transportation. Frozen fruits and vegetables. Many fruits suffer substantial damage on freezing due to osmotic changes, ice formation, and destruction of cell membrane due to the formation of the ice crystals, which is mentioned over here. The majority of frozen fruits and vegetables are packed in plastic film, such as deep freeze grades of PE, made into pillow type packs on vertical form fill seal machines. Vegetables are packed commonly with LDPE as a moisture barrier. EVA bags for large quantity that are strong enough to carry the weight, offer the necessary moisture barrier, have good heat seal properties, and remain palatable at freezer temperatures as well. Reclosable feature on the package is often used. In this case, some soft fruits such as raspberries are packed in leaded plastic containers. The barrier properties of paper and paper boards. So we can see the different barrier properties of the paper and the paper boards. The poor barrier to gas, including water vapor, under which, so to improve the barrier properties and physical characteristics, these materials can be laminated with plastic. These materials, that means we are talking about the paper board and the paper, and with plastics, that is specifically for the polythene, or can be coated with wax of the glaze. Waxed papers are alternative in applications requiring direct contact with food as a barrier against penetration of liquids and vapors, as well as the heat solubility, lamination, and even printing. So we can see the waxing concept, that is wet waxing, where the wax coated is applied to the surface of the paper or card sheet. This is desirable for heat sealing and lamination and is essential for vapor barrier development. Second one, dry waxing under which, where the wax is absorbed into the sheet and often does not look for feel waxy. Okay, so this is a nice point over here. The next, that is such treated papers. Such paper and the paper boards and the sheets which are treated papers allow free transmissions of the water vapor and the gases. So this provides the protection against loss or gain of moisture, high initial gloss and good gloss retention, scuff and abrasion resistance. Now we have seen the different packaging material in the different process for the frozen foods. So all kind of the packaging materials and for the different food materials, and at what temperatures, what kind of packaging system is there, we have seen. So in this slide we try to know that what are the future trends nowadays. So a variety of primary packaging are currently employed, including plain, coated, metallized, laminated plastic films, leaded plastic trays, and thermoforms often contained in the paperboard sleeves or cartons. To extend keeping times and the better quality of frozen food at -25 to -30 degrees Celsius, it requires the capability of withstanding these significantly lower temperatures without embrittlement. In case of mechanizing transparent packaging, the anti-fogging bags are required, which can give an advantage to chilled foods on display, whereas frozen foods will spoil the transparency due to deposits of frost because of the below zero temperatures. The use of susceptors to provide browning and crisping of pizza or fish steak cases has received much attention and is a field that has still to be developed further. The much emphasis will also be placed on the environmental protections. So along with the packaging materials and the recent developments, we need to see what kind of situations are being occurred on the environment as well. So in the technological interventions and the understanding, we have to see how our technology is affecting the environment. So there must be sustainability approach in order to develop the technology to enhance the shelf life and the quality of the products, how it should be stored, and at what kind of packaging material should be used. So a holistic approach is required nowadays. So through this module, I hope the audience and the stakeholders will try to know a good idea of the packaging of the frozen foods and even what kind of packaging is required during the storage under the refrigerated and the frozen conditions. Thank you.